Welcome to this lecture on life on Mars. It's been given by Dr. Joshua Nall for the Herschel Society and the Bath Royal Literary and Scientific Institution. My name is Tony Symes and I organise the lectures for the Herschel Society. Please be aware that this lecture is being recorded. So I'm delighted to be actually in the RLSI for the first time since the pandemic with the lecturer and a small audience in the room. We have a larger audience attending the lecture on Zoom. And as always, I ask the people on Zoom to make sure that they stay on mute during the lecture and also keep their video off. You can turn your microphone and video stream back on for the Q&A session afterwards. And during the lecture, if you have any questions, please type them into the chat channel if you're on Zoom. If you're in the room, you'll have to wait until the end of the lecture. And we'll attempt to deal with questions both from the room and from the chat channel on Zoom. Now, we're having a little bit of a theme on Mars at the moment. This is partly because there's a lot of robotic exploring vehicles out there at the moment. And we're going to start off this evening by looking back to the Victorian view, and then next lecture is going to be entitled Mars, Ancient Rivers, Lakes and Oceans, but Where is the Water Now? And that's going to be on Friday the 5th of November, and it will be a remote-only lecture because the lecturer will be Michael Carr, who is based in California and has had an impressive career with NASA from 1970 to 2004, especially being involved with imaging. Back to tonight's lecture, I'm very pleased to have Joshua Nall. He's Curator of Modern Sciences at the University of Cambridge's Whipple Museum of the History of Science and is a historian of 19th and 20th century astronomy. Let me hand over to Joshua.
Okay, thank you very much, Tony, and thank you for having me, and thank you for people coming in the room. This is, ask you to start your video. Do I press start video? There we go. Can people see me? People can see me? People can hear me?
Yes.
Okay. I apologize in advance to people online if I wander out of shot. I tend to wander around when I'm talking, but I will endeavor to stay in shot. This is a pleasure and a slightly unusual experience in that I'm pretty sure that this is the first lecture I have given to actual in-person humans since early 2020. So it's wonderful to finally be back. Term starts for me next week, so I start giving in-person lectures again next week. So this is a wonderful opportunity to get back into the nice, pleasant feeling of actually talking at real people. Thank you, of course, to Tony and to the Herschel Society for having me. As he explained, I'm a historian of science, a historian of astronomy. So everything I know about Mars is about Mars in the 19th century, more or less, or long 19th century. But hopefully this will give you an interesting counterpoint to the lecture you're going to get about water on Mars today, because a lot of what I'm going to be talking about is water on Mars in the 19th century. Now, let me see, can I get this clicker working? Bear with me. Yes, that's working. So what I'm going to do, I want to start at the end. I like to start here at the end of my lecture. So this is where we're going to get to. And this may ring some bells to some of you. This is a very famous event in the life of Orson Welles that happened in 1938. And this was a radio broadcast that Welles and his team at the Mercury Theatre did of H.G. Wells's famous novel, The War of the Worlds, in which Martians invade Earth. And rather notoriously, when Welles launched a radio broadcast of this, he moved the location of the story from leafy Surrey to New Jersey, and he recharacterized it in the terms of a live news report of the Martian invasion. And although it was announced that this was an adaptation of a fictional novel at the start of the broadcast, many people tuning in late did not realize that they were listening to a fictional adaptation and thought they were listening to a real live broadcast of Martians invading New Jersey. And as you can see here with these headlines, it caused something of a panic. There's a lot that could be said about this broadcast, but what I really want to focus our attention on here is the rather simple fact that for this panic to have happened, a large number of people had to have believed that it was plausible that Martians would invade Earth. And that doesn't seem plausible to us, and what I hope to show you over the course of the next 45 or so minutes is that it was much more plausible to people back in the 1930s. So having started at the end, I'm now going to go to the beginning. And of course, here, speaking in Bath to the Herschel Society, I can't help but begin with the great man himself, William Herschel. Herschel is a very good place to start any story about extraterrestrial life, because certainly in this country and in English-speaking world, William Herschel is one of the kind of founders of the popularization of an idea of an inhabited universe. William Herschel, he wasn't the first person to talk about the idea that the universe might be filled with life, but he was hugely influential in promoting this idea of extraterrestrial life. So Herschel, working here in Bath as a musician, got interested in astronomy as an amateur astronomer, began building his own telescopes, read the works of a number of popular astronomers, including particularly James Ferguson, who had already written a number of books advocating the idea that there were extraterrestrials throughout the universe. And Herschel found this idea very appealing. It's an idea that I may refer to throughout this lecture with another phrase, which is the term of art that people used in this period. That phrase is plurality of worlds. This was what they talked about. Is there a plurality of worlds or a plurality of inhabited worlds? So if I use the shorthand plurality, that's what I mean. It's an argument that instead of the Earth being alone and unique in the universe, that actually it's just one amongst a plurality of inhabited worlds. So even by about 1780, before Herschel has become a famous astronomer, he starts observing the moon and he starts communicating with the Royal Society on his observations of the moon. And this is a letter that he writes in June of 1780 to the Astronomer Royal, where he says, "Who can say it is not extremely probable, nay, beyond doubt, that there must be inhabitants on the moon of some kind or other? I hope and am convinced that sometime or other very evident signs of life will be discovered on the moon." So it's been argued, in fact, that one of the drivers for Herschel beginning to build bigger and bigger telescopes was that he was committed to a mission of trying to prove the existence of life on the moon. Of course, within a year of this letter being sent to the Royal Society, Herschel had become world famous, not for discovering life on the moon, but for discovering a new planet, Uranus. And that launched him into the sphere of international fame. He becomes astronomer to the king. He gets given lots of money to build bigger and bigger telescopes. And with that comes wider popular and public discussions of Herschel's promotion of an idea of extraterrestrial life. So one of the, sorry, something's gone horribly wrong there. Back up. One of the pieces that I particularly like, do I have a way of moving this? Oh yeah. It is. Thank you very much. Can you also see me up there? That's rather boring, isn't it? Let's get rid of me. There we go. I hope others can still see me. I don't think that's got rid of me. I hope people on Zoom can still see me. Can you still see me? Okay, excellent, good. So this is an article that I particularly like. Sorry, I've gone to the wrong page. Sorry, this clicker may be more trouble than it's worth. I think maybe I have. This is an article from the local newspaper, the Bath Chronicle, in 1793, reporting the fact that they hope that Herschel will soon be able to report the discovery of life on the moon, including an edifice bigger than St. Paul's Cathedral. Now, Herschel wasn't ever able to definitively prove that the moon was inhabited, but that didn't dampen his interest in and belief in extraterrestrial life. The basis for that belief was actually as much theological as it was scientific. There were two kind of abiding principles that governed not only William Herschel's interest and belief in extraterrestrial life, but wider acceptance of the idea of extraterrestrial life. We can call one of these ideas the Copernican principle. This is the idea that after Copernicus, the Earth stopped being recognized as a particularly special or unique body within the universe. It went from being the center of the universe, stationary at the middle, surely the only inhabited orb, to being just one planet amongst many, orbiting a sun, and therefore it could just be a pattern of many, many worlds. And the second principle, okay, I'm going to stop using this. This is, it's okay, I'll use the keyboard, and it's obviously going a bit mad. The second is the principle of plenitude, this idea that God would not create such a vast universe with so many suns in it, which must themselves have so many planets, and then only populate one. That would be wasteful. And what Herschel does is, and what's special and important about Herschel's work, is he marries these theological principles to an observational program in which he wants to observe, in a way he describes it himself as, he wants a natural history of the heavens. So he wants to observe celestial objects, categorize them, and understand them as part of a wider living universe. So he didn't just believe in life on the moon, he believed that, in fact, all planets were likely inhabited. And I think most remarkably, we can see here, so he says that we have suns sustain a system of planets that serve for the habitation of living creatures. He even argued that the sun appeared to be nothing else than a very eminent, large and lucid planet. Its similarity to the other globes of the solar system lead us to suppose that it is most probably also inhabited, like the rest of the planets, by beings whose organs are adapted to the peculiar circumstances of that vast globe. So you can see that as we turn into the 19th century, one of the world's most preeminent astronomers is comfortable arguing that not only is the moon inhabited, not only are all the planets in the solar system inhabited, maybe even the sun is inhabited. So plurality is absolutely a dominant narrative of astronomical discourse at the turn of the 19th century. And this passes on to William's son. So John Herschel, who I can't say more about here today, but hopefully those of you in the society know, John Herschel not only adopts his father's interest in astronomy, but he adopts his fame as well. John will go on to become just about the most famous astronomer in the English-speaking world across the 19th century, through to his death in the early 1870s. And you can see here from this quote that John also is a keen advocate for the idea of a plurality of worlds. And again, we see this kind of theological tinge to it, that who can suppose to be man the only object of his creator's care? But the event that really cements John Herschel's reputation as a promoter for the plurality of worlds is, of course, his discovery of bats on the moon. And you can see here from this quote that we have, this is so the story goes, a first-person account from John Herschel of observations that he has made in South Africa at the Cape of Good Hope. He's working at the Cape in South Africa in the mid-1830s, and as we see here, the New York Sun reports that Herschel has written a letter back describing, using a new telescope with much more magnification power than any previously known telescope, and describing the creatures on the moon that he has seen, including batmen and horrible goat monsters. And this, of course, creates a huge sensation. It becomes international news. And it is, of course, also a hoax. It's reported first in the New York Sun, is widely then syndicated and distributed around the world. The first time John Herschel hears that he himself has discovered bats on the moon is several months later, because he is at the Cape in South Africa. But it creates a press sensation. And one of the reasons that I really want to highlight it here is it reiterates this point that in this period, not only the idea that there could be bats on the moon, the idea that someone like John Herschel would discover them was common currency. And although, of course, it was a hoax, historians have subsequently argued that in a certain sense, the piece by the Sun, it wasn't just written to try and get readers to buy their newspaper. It's also been argued that the journalist who wrote it as a satire of what he thought was some of the more outlandish claims that were coming out in popular astronomy at the time. And for John's part, we can see, even sequestered in South Africa, he wrote back to his aunt, Caroline, "I have been pestered from all quarters with that ridiculous hoax about the moon," in English, French, Italian, and German. So by the middle of the 19th century, arguments about the existence of extraterrestrial life in the universe had become mainstream in scientific and theological discourse. Exemplary is an argument that springs up in the early 1850s between the Cambridge liberal Anglican scholar William Whewell on the left, who publishes anonymously a book called Of the Plurality of Worlds. And in this book, Whewell argues against the plurality of worlds. He argues that there is only life on Earth. And Whewell's argument, again, broadly a theological one, he comes back to Scripture and says there is no account of extraterrestrial life in the Bible, and therefore humans are indeed unique within the universe, and life is unique on Earth. Fighting back against him is the Scottish evangelical David Brewster, who writes More Worlds Than One, The Creed of the Philosopher and the Hope of the Christian. It's a broadside against Whewell, attacking Whewell for claiming that there is not life in the universe on the grounds, as I said, of this idea of plenty. Brewster argues it is absurd to suppose that God would create so many stars, so many suns, and only populate one of them. But important for what I'm about to say about Mars is Whewell's comeback is rather compelling. What Whewell says is actually we don't know that any other object in the universe is like Earth. We don't actually know that stars are suns. We think they might be suns, but we don't know, which means we don't actually know that there are any other planets in the universe other than in our solar system. And we don't actually know that any of the objects outside of Earth are made of the same materials that the Earth is made of. And so what sustains life on Earth, the material elements that sustain life on Earth, may not exist anywhere else in the universe. And this is an argument to an extent which astronomers can't really help with, or most astronomers can't. I'm showing you an image here of the typical practices of, in this case, this is the Greenwich Observatory. Most paid astronomers are paid to chart the motion of celestial bodies in order to regulate things like time and contribute to practices like navigation. We have a nice quote here from 1859 from Benjamin Apthorpe Gould, the director of the Dudley Observatory in New York, explicitly repudiating any claim that he can help in any way with the kind of debates that William Whewell was so interested in. The science of astronomy consists in the investigation of those laws which govern the motion of the heavenly bodies. The natural history of the heavens, although a cognate and most interesting field of inquiry, is not included in the domain of astronomy proper. So on this account, as interesting as the debate about extraterrestrial life is, it comes across more as a theological question or a philosophical question than as one that astronomy can help. But strikingly, and the reason I've chosen this quote, is that this quote was given, the date of it is in the same year that a profound and groundbreaking new discovery completely overturns much of what I've just described. Some of you may have been thinking 1859, I'm going to talk about Darwin. I'm not talking about Darwin here. I'm a historian of astronomy, much more important than Darwin. 1859 is the first account of Bunsen and Kirchhoff's work on the spectroscopic identification of chemical elements by the analysis of light using this device here, the spectroscope. And what Bunsen and Kirchhoff were able to work out, and this is a profound insight into not only chemistry on Earth, but actually the entire universe, is that you can analyze the spectrum of light to determine the chemical elements present in the material that has emitted that light. What they found is that if you take a very pure element, I'm going to pick on sodium here, and in the laboratory, you energize that element, it emits light at what we would call a very particular wavelength. This is the sodium line. But then what they noticed was that if you look at the solar spectrum, there are dark bands that correspond with these particular elements. And what they surmised and what they were able to show was that that means that the light from the sun has passed through something with sodium in it, which is absorbed in the sodium band. So if you energize sodium, it emits, but if you pass light, a full spectrum of light through sodium, it absorbs. So what could they say? They could say that in the sun, somewhere in the sun, there is sodium. There has to be, because the light has gone through sodium before it has got to Earth. And so with this, you could suddenly analyze the chemical composition of heavenly bodies. This is a profound transformation of our understanding of the universe, and it enables people like William Huggins and William Miller to analyze, as we see here on the spectra of some of the fixed stars. They can report suddenly that actually William Whewell's argument that the universe, we don't know what the universe is made of, it might not be made of anything like what's on Earth, that argument cannot stand. Because actually the universe is made of exactly the same chemical elements as we find on Earth. So you see in this quote, not only are William Huggins and William Miller able to report that it is remarkable that the elements most widely diffused through the host of stars are some of those most closely connected with the constitution of living organisms of our globe, including hydrogen, sodium, magnesium, and iron. They go one step further and conclude, on the whole, we believe that the foregoing spectrum observations contribute something towards an experimental basis on which a conclusion hitherto but a pure speculation may rest, viz. That at least the brightest stars are like our sun, upholding and energizing centers of systems of worlds adapted to be the abode of living beings. So this is an extraordinary, profound, transformative insight. William Herschel would have been delighted with this upheaval of the astronomical discipline, because now suddenly Whewell's argument evaporates and we actually can say, yes, well, actually, we can analyze the composition of celestial bodies. And of course, one of the first things that William Huggins does, which will be important for us in a minute, is he looks at Mars and he then immediately reports the detection of water there, a result which we now think was in error, but at the time was taken very seriously. So we start to see things like water on other planets. I said I wouldn't talk about Darwin, but I will actually talk about Darwin, because Darwin, of course, is part of this story. I can never escape Darwin as much as I want to, because, of course, Darwin brings another facet of scientific understanding to any debate about extraterrestrial life, because one of the things that the Darwinian theory of evolution by natural selection does is it suggests an extremely longue durée history for the development of life on Earth. Life has evolved over a very long period of time, progressively and developmentally. This gives a model potentially usable throughout the universe. And when you marry that to a very popular theory for the development of celestial bodies, and this is a theory that we owe a great deal to William Herschel for, which is called the nebula hypothesis, the conception that solar systems form by the condensation of nebulous swarms of gas slowly into and condense into a central sun with planets orbiting them. You start to get a life history for the solar system. And one of the things that becomes important and interesting for the story I'm going to tell about Mars is that this body forms from the outside in, which means that each planet has its own life history and duration, but they're different. The outer planets are actually older than the inner planets. This became particularly of interest to this man, one of the heroes of my research, a British astronomer named Richard Proctor, extremely successful and popular in his day, rather forgotten to the sands of time, but he was a huge figure in his day. And Proctor takes a particular interest in the planet Mars. He's particularly interested in Mars because he thinks that Mars is very like the Earth, and he thinks that Mars may be a good candidate to be a living planet. So I'm showing you here a chart, a new chart of Mars that he publishes in 1870 in a book called Other Worlds Than Ours. And in that book, he makes a rather bold and important declaration. He says, given the evidence of the spectroscope, given the evidence of Darwinian evolution, given the nebula hypothesis, actually, until it's been demonstrated that no form of life can exist upon a planet, the presumption must be that the planet is inhabited. So, of course, Mars becomes a particular focus of attention because Mars, through the telescope, appears to look quite a lot like the Earth. So this is a view of Mars based on Proctor's map. So we're talking about observations made in the late 1860s. This globe dates from 1872. So at this time, through the most powerful telescopes, Mars is notoriously difficult to observe. It's probably at best, through a telescope, looks about the same size and shape as the moon does to the naked eye. So if you imagine going out right now and trying to map the moon, just standing in the square with a pencil and paper, you get a sense of how tricky it might be. Plus, you can only observe Mars for about 2 weeks, once every 2 years. As I'm sure many of you know, it only comes into opposition, close approach to Earth, once every couple of years. But that doesn't stop Proctor from declaring, importantly, that Mars is very, very Earth-like. Throughout the whole of the solar system, there's no object which affords so many points of resemblance to our own Earth or exhibits so clearly the signs of adaptation to the wants of living creatures as Mars. It presents a scene which requires no very lively exercise of the imagination to dot with villages, towns, cities, peopled with busy workers. So you can see how this longer history of extraterrestrial life and interest in extraterrestrial life throughout the universe starts to channel down in the mid-19th century to the planet Mars, in part because Mars is astronomically considered to be the most similar object in the solar system to the Earth. And importantly, and this is an essential point, and this is also a point that you will find today, I make this point whenever I talk to astronomers today who work on exoplanets, you have to recognize that the only way that people like Proctor can really work effectively to try and begin to construct the life history of a planet like Mars is to use analogy, to extrapolate from what we know about Earth and project it onto Mars. So one of the things that I want to stress about this is that, and you'll see this as I move through our discussion of Mars through the second half of the 19th century, one of the things I want to urge an understanding of is the idea that Mars becomes a screen onto which astronomers, commentators begin to project earthly interests and concerns, and they start to see in Mars facets of the Earth as it is, and importantly, for what I'm about to say, the Earth as it will be. Because as I said, the nebula hypothesis posits that Mars forms before the Earth. And so in a certain sense, Mars starts to become seen as a future Earth. It's an older planet Earth. And this means that its geology and its ecology become very important, but of course are very difficult to study. But one of the most important episodes that begins to bring this into focus is the development of new maps of Mars after 1877. There's a particularly good opposition in 1877. The Italian astronomer Giovanni Schiaparelli observes Mars from Milan. He produces a completely new map, and he says actually Mars has much less water on it than Proctor saw. The only water on it tends to be grouped in quite narrow bands, which he calls canali. This is picked up by a number of astronomers who begin to see more and more of these canali. And we see here, for example, in the account of the famous French astronomer Camille Flammarion, the argument that Mars begins to be seen less and less as an Earth with large continents and large oceans, and more as a planet that is mostly arid and dry, almost perhaps a desert planet, but that is crisscrossed by these dark straight lines. And so the question starts to become, are these canals natural features of Mars, or are they artificial features? Are they actually canals rather than channels? Have they been built by intelligent Martians? This sparks off a great debate. Of course, my hero, Richard Proctor, can't help get involved. This is a letter he writes to the Times in 1882, which is published on their letters page, where Proctor wades into a debate that has begun to rage about whether or not these lines that you can see on Mars are artificial or natural. And Proctor, this is a wonderful example of kind of engaged hedging of your bets. He says, should it be proved that a network of dark streets has real existence, we should by no means be forced to believe that Mars is a planet unlike our Earth, but we might perhaps infer that engineering works of a much greater scale than any which exist on our globe have been carried on upon the surface of Mars. And then he concludes, it would of course be rash, however, to presently speculate in this way, which of course he has speculated in. And this kicks off a huge amount of popular excitement over the prospect that Mars is not only inhabited, but is inhabited by a race of superior Martians who can build engineering works on a scale visible from Earth. And this is a debate, and not everyone agrees. J. Norman Lockyer, the founding editor of the journal Nature, gets very upset when people start reporting what they think are light flashes from Mars. There's a whole series of reports that suggest that Mars may be signaling to the Earth. And Lockyer writes angrily in his own journal, the widespread notion of the signals from Mars rests only on a mistranslation of the word canali, which he says should have been translated as channel, but got translated as canal, and upon popular imagination running riot. So this is the exact context in which we should pause and think about the production of H.G. Wells's novel, The War of the Worlds. Because Wells writes his novel between 1895 and 1897. So Wells is writing in the absolute white heat of this debate over canals on Mars. And the other thing that we have to understand about Wells is that Wells was a science writer as well as a novelist. And he was very interested in the power of blending those realms. He called his work scientific romance. And he said explicitly that his aim was to bring contemporary science into dialogue with fictional accounts. So you'll have to excuse the rather long quote, but I think that it really goes some way to bringing out the way in which Wells drew into his novels the contemporary debates about Mars. Since Mars is older than our Earth, this is from the very beginning of the novel. It necessarily follows that it is not only more distant from time's beginning, but nearer its end. The secular cooling that must someday overtake our planet has already gone far indeed with our neighbor. Its air is more attenuated, its oceans have shrunk. That last stage of exhaustion, which to us is still incredibly remote, has become a present-day problem for the inhabitants of Mars. and looking across space with instruments and intelligence such as we have scarcely dreamed of, they see a morning star of hope, our own warmer planet, green with vegetation, grey with water, with a cloudy atmosphere, eloquent of fertility. So what do those Martians do? They build spaceships, they travel to Earth, they invade in order to harvest human blood. And obviously a lot of different narratives have been read into this novel. It's long been argued that this is really a novel about colonialism and British imperialism. But it's certainly, I argue, also a novel about contemporary concerns about the ecology of Mars and life on Mars, but also with it reflected back broader concerns about the ecology and the future of the fate of Earth. To dig into that idea a little bit more, we need to understand the work of this man, Percival Lowell, an American astronomer who's typically taken to be the most successful advocate for an argument for life on Mars. And we know that H.G. Wells read Lowell, and we know that Lowell read H.G. Wells, and we know that the men were friends. But Lowell very much characterized himself as a serious astronomer. He built an observatory in Flagstaff, Arizona, specifically committed and dedicated to the observation of Mars. He absolutely and passionately believed that Mars was a living planet, and these are the maps that he ultimately produces of Mars. And so this is the apotheosis of the conception of Mars as a living planet completely crisscrossed with canals. On Lowell's Mars, there's effectively no standing water. It's a desert planet. It has polar caps of water. But as these polar caps melt, the meltwater is channeled through a massive system of irrigation canals in order to irrigate the crops. So the green is what the Martians are growing, and the irrigation of these crops and the crops that grow alongside the canals are based on these network of canals. Central to this conception of Mars for Lowell is the idea that Mars, as we saw with H.G. Wells, Mars is a dying planet. It's older than the Earth, it's colder than the Earth, it's lost more of its water than the Earth, and it's beginning to face ecological collapse. But in the face of that ecological collapse, we see great engineering works. So Mars, in this conception, becomes something as a harbinger of the fate of the Earth. So Lowell is interested not only at looking at the Earth and asking, what can the Earth tell us about Mars? He's also very interested in looking at Mars and saying, let's run the analogy both ways. What can Mars tell us about the Earth? And I'm showing you this juxtaposition because this is a juxtaposition that he makes in one of his own books, Mars and Its Canals. This is a photograph of Hyde Park that he took from a hot air balloon. And he uses this as an example to show how if you look down on Earth, you start to see the same man-made patterns that he can see through his telescope. But importantly for his conception of Mars as a dying planet is a broad argument, an ecological argument about the decay of the planet and the death of Mars, but also, importantly, engineered solutions launched as a defense against that decay. So one of the things that he points out is that on Earth, we're beginning to see the beginnings of the ecological decay that are much further forward on Mars. He writes that the Caspian Sea is disappearing before our eyes, as there remains some distance from its edge of what once were ports mutely inform us, the Earth then is going the way of Mars. Deserts represent the general unspeakable death grip on our world. They mark the beginning of the end. One of the reasons that I'm particularly interested in this particular narrative of ecological decay and responses to ecological decay is its link, I argue, to particular concerns around ecological collapse on Earth, specifically the catastrophic droughts and famines that affected large swathes of the British Empire in the late 19th century, particularly as we see here from this distressing image from the Illustrated London News, showing an image from one of the Indian famines of 1877. Between 1877 and 1902, somewhere between 12 and 29 million people starved to death in India under British colonial rule. This, of course, is a human tragedy. It's also a political scandal. It's an outrage. It's a disgrace. It's been, I think, very cogently argued causes of this was not simply the failure of the monsoon rains, but more broadly the bringing of the Indian grain economy into the British Empire's grain economy, and so the continued export of grain out of India during the famine and the refusal of the British Raj to lower grain prices in India contributed to these massive famines. But one of the British responses to these famines was to launch a series of scientific claims for their naturalness. And so it's very telling that certain astronomers explicitly linked the message that Lowell found on Mars to our understanding of these messages of what were characterized as natural ecological disaster on Earth. So this is H.H. Turner, Oxford's civilian professor of astronomy, speaking at the Royal Astronomical Society about Percival Lowell's account of Mars. And Turner defends Lowell by saying it is difficult for us in England to recognize what men will do to get water. Here in England, we have plenty. But when one goes to such parts of the world as where Professor Lowell has his observatory, which is Flagstaff, Arizona, in a high desert, it can be realized what people will do to get it. In a country like Egypt, one may see how every man who can be spared for the purpose is made to ladle water from the river in buckets. If we had not gone to Egypt with our big engineering works, that would be the state of things at this moment. If then we give play to our imagination, we may be able to understand the naturalness of Professor Lowell's suggestion. So there are two parallel claims being made here that I think are very important for understanding man's understanding of Mars and the Earth at the time. On the one hand, there is a claim about the naturalness of what's happened on Mars. It's old, it's decayed, it's lost its water, it's faced ecological catastrophe. On the other hand, there is a claim about the solution to this problem. And that is, of course, the triumph of industry. Lowell is not only arguing that Mars is a harbinger of Earth's future, Lowell is also arguing that industrial capital is clearly the solution to the problems that will face Earth, because it's the solution that he identifies on Mars. And he's explicit about this in his books. He says, increase of intelligence would cause one species to prevail over its environment. This species will thus become lord of the planet and spread completely over its face. And that's what you're seeing on Mars. One super race which has built canals to systematically subjugate a planet which was otherwise facing complete ecological collapse. And it's not hard to see where a narrative like this would come from if you are a captain of industry like Percival Lowell. Lowell is from the Lowell family in New England. You may have heard of the name Lowell. There's a town named Lowell. The family of Lowell are not named after the town. The town is named after the family because it was established by them as one of the towns for the workers of their many, many industrial concerns. Lowell were one of the richest families in New England. And so Percival Lowell came from a long line of industrial capitalists. And of course, he's writing about the triumph of canal work at exactly the moment that we begin to see human endeavors to impose this kind of engineered solution into the lived environment. And this is exactly the way that these stories get conceptualized and spread and popularized in the news. So on the left here, we have a story from 1910 or 1911 in the New York Times. Martians build 2 immense canals in 2 years, vast engineering works accomplished in an incredible short time by our planetary neighbors, wonders of the September sky. And this is Percival Lowell here, the prophet of these vast engineering works. And we see here on the right this account of Lowell. Shoremen dug the trenches, elaborate system of monster sluiceways. And of course, this is easy to reflect back on humans now and potentially what humans can achieve. So here, the Brooklyn Daily Eagle in 1907 argues, so the Lowellites reason, necessity being the mother of invention, the Martians dug the huge canals. If there are powerful telescopes on Mars, they are smiling frequently, perhaps, over the fuss and bother this country is making of digging, in their eyes, a mere little trench across the Isthmus of Panama. And just as the state-of-the-art technology when Lowell is writing in the 1890s is canals, so as technology advances, so do humans' conception of what the Martians themselves are able to technologically achieve. They track, unsurprisingly, a historian would argue, rather side by side. So by the 1920s, what we find are repeated accounts that Martians are not necessarily just building canals, they are also building radio antenna to signal Earth. And so in the 20s and 30s, you start to get more and more accounts of attempts to listen to and send signals to Mars. So Nikola Tesla has an extended program where he claims he thinks he has detected signals from Mars, and he also makes claims that he will begin sending signals to Mars. This is a telegram from the, I believe, the Secretary of State for the Navy, asking all US naval radio stations to listen out for signals from Mars as Mars comes into opposition in 1924, August 24, particularly good opposition of Mars. And lo and behold, radio signals are then perhaps detected. Weird signals start to be detected, recorded on film. The recording of radio messages onto film is a very new technique in the early 1920s. And an astronomer at Amherst University, David Todd, is able to start recording what he thinks are messages from Mars onto film. He then says that it looks perhaps like the messages are making out the shape of a face. So this starts a large number of reports that Martians are actually broadcasting the image of a face, which leads to certainly my all-time favorite letter to the editor. This was a letter to the Christian Science Monitor, explaining this message by arguing that possibly there is nothing left of the inhabitants of Mars except heads. So clearly that's our evolutionary fate, is that we are going to evolve to become giant heads that build canals on Mars and then send radio signals of our giant heads to the next planet over. So that then takes us to the end. That, I think, gives us a much better, I hope gives us a much better understanding of why in the late 1930s it would still be possible for people to panic when they heard a radio report that Martians had landed in New Jersey and had started vaporizing people with lasers. Sorry, that's anachronistic, not lasers, with ray guns. The 1930s is at the end, but not quite up to the point where widespread belief in not only a living Mars, but an intelligent living Mars was common currency. And actually that idea only ultimately gets knocked on the head once probes begin to be sent to Mars in the early 1960s and send back images of the planet, which I have been told by a number of eminent and now very senior astronomers who were alive at the time with some of the most disappointing scientific data ever to be sent back, showing a completely arid, dead planet. And that then starts a whole new series of research looking not for life on Mars now, but looking for life on Mars in the past, which is what you'll be hearing about in a few weeks' time. So I will end there. Thank you very much. Happy to take questions.
We don't have any keep an eye on it.
Yeah.
It's more of a when the Proctors Map came back from the Voyager orbiter in the late 19th century, they showed a lot of detail, not too bad before. And they showed a lot of structure interpreted by geologists. I did a test. I took the map, I photocopied them onto transparent film. That's the level of technology that was available. Projected them with an overhead projector and then defocused. And an amazing proportion of any audience would start to see video.
Mm-hmm. Yeah. Yeah. Well, absolutely. I mean, one of the stories I didn't talk about at all. I can, yes, certainly. So the question was about the perception of lines on Mars and where does this come from, told from the perspective of our gentleman in the audience here who took some of the 1970s images, photograph maps of Mars that were produced after Voyager. It was Voyager, wasn't it, in the 70s? Mariner in the 60s, Voyager in the 70s. Put them onto transparent slides, projected them, and then dimmed these images until you only, or defocused the images until you only got kind of disparate detail and patterns. And if you defocus enough and you stand far enough away and you ask people to draw what they see, they will start to draw lines. They will start to draw patterns and lines between disparate objects, which if you had it at high focus, would actually be individual points. They would be craters, they would be volcanoes. And this is a really interesting point because one of the things I didn't talk about at all, but which I have looked into, is that this point did not escape the astronomers of the late 19th century. And in fact, opponents of the idea of canals, so I only showed you in this whole talk one astronomer grumbling that the canals don't exist, J. Norman Lockyer. But there were plenty of astronomers who disagreed with Percival Lowell and thought that he was wrong. And one of the things that they did was they ran exactly the same test that you're describing. One of them was an astronomer at the Royal Observatory. I'm blanking on his name. But anyway, his test was he took some round images. He drew on a kind of mock-up drawing of Mars, but only using dots. And then he took it into a Greenwich school. E. Walter Maunder is the guy's name. He took this chart into a local Greenwich school, pinned it against the wall, and asked the schoolboys to draw what they saw. And what he found was that the further away that the schoolboys were, the more lines they drew instead of individual dots. So by the time you got to the back of the room, they just drew lines. And the reason he did it in a school with schoolboys is he said that he wanted completely disinterested observers, unbiased observers, people who didn't know what they were even being asked to do. And so one of the arguments that Lowell makes when this is published is he says, well, that's rubbish because schoolboys don't tell you anything, because schoolboys don't know what they're doing. I'm a professional astronomer. I've spent my life observing. I know the difference between a blob and a line. So then an American astronomer who also doesn't agree with Lowell, named Simon Newcomb, runs the same test, but only using professional astronomers. Does the same thing, pins up the chart, illuminates it by reflected light, gets them to sit different distances away, gets them to draw what they see, and he then publishes these drawings, and lo and behold, they have lines on them, because the eye is conflating detail into patterns, because the eye, you want, below a certain resolution, you want to try, and the eye wants to try and kind of construct and tease out what patterns it can. So there's a whole nother lecture I could give you about arguments over whether or not what they were seeing really existed. Brilliantly, Lowell's response to Newcomb, because he couldn't now respond, well, schoolboys are pointless. Lowell's response to Newcomb is, just because A causes effect B doesn't mean that B doesn't cause effect B. He says if there really are lines on Mars, that would also cause lines. Just because dots do doesn't mean lines won't. So he retorts by saying what you should actually be doing is observing straight dark lines at different distances to see how far away you can make out narrow dark bands. And he does this with telegraph wires. And he then publishes a counter paper saying that actually bands as narrow as 2 miles across on Mars would be observable on Earth, which of course he has an explanation for that. I know what you're thinking. A 2-mile wide canal is a big canal. His argument is that you're not seeing the canal. What you're seeing is the vegetation that is being grown on either side of the canal. And the reason he says this is that one of the things about his map, the globes are a bit misleading, is that he freely admits that some of the canals disappear and reappear. And you don't ever see all of them. You only ever see some of them whenever you look through the telescope. And so he says that's indicative of their crop cycles, etc. So that's a wonderful and delightful story of doing that exact experiment. And in fact, I can give you another one, which was done by a colleague of yours in the 1960s, Carl Sagan, a name that will be familiar to most astronomers. One of the first things Carl Sagan did when the Mariner images came back in the 60s, which Mariner only imaged a very small portion of Mars. Voyager was able to do the whole planet, but Mariner only gets sent back certain images. But Sagan was able to take areas of Mariner that could be clearly located even on a Mars map. And the reason that you can clearly locate them is that there are certain features on Lowell's maps which are still to this day easily identifiable as obvious features. One of them is called Syrtis Major. This is very large. It kind of looks like a tornado, huge dark triangle. And so by looking at where Lowell has lines in relation to Syrtis Major, Carl Sagan overlaid Lowellian maps onto the Mariner photographs. And actually what he says is that he was hoping that it would be a perfect overlay, but he says actually you can't. He was expecting to be able to show that all of the canals were linkable to Mars features, but actually he said you couldn't actually directly link them to specific features. And so some people think this suggests that it wasn't so much individual craters and volcanoes that people were seeing as potentially things like the boundaries between lowland areas and highland areas, where you have a contrast in tone, can appear at low enough resolution like a dark line. So yeah, it's a fascinating question, but I think it's important to say that in the 19th century they were aware of these issues. Yeah. I fear this is. I should reiterate my caveat that I'm a historian rather than a scientist. So my answer to this will be pretty limited. The question is, we're told that for life you need water. Why water? Why not any other complex molecules or chemicals? Yeah, I think it's a good question. But interestingly enough, it's almost taken as a given that water is a prerequisite. In the accounts I'm looking at in the 19th century, the presence of water on Mars, which, as I say, in 1867, Huggins detects water on Mars with the spectroscope, which we now suspect was an error caused by the problem that he always faced, which is that light coming from Mars comes back through the Earth's atmosphere. So if you're looking for an absorption line for water, you will get one because the light is coming through an aqueous atmosphere. So you will definitely get one. So what Huggins was trying to do was to look at the moon, and then which was presumed to be completely water-free, and then look at Mars and see whether the absorption line was stronger for Mars than the moon. And he said it was. So he says there's water on Mars. And this is hugely significant because once there's water on Mars, people like Proctor can say, well, we should presume that there is life because that's a key condition. I don't remember seeing any of my historical actors really making the case necessarily that you could have what we would call life systems without the presence of water. And I don't know whether that's just a kind of a failure of imagination or whether if there are good scientific arguments for it. I have to confess, I'm not. The last time I looked at a science textbook was as an undergrad, and I can't give the answer that an astronomer now, an exoplanet astronomer now would give, because of course astronomers looking at exoplanets now are again acutely interested in the question of water. And you will hear, I mean, the simple answer actually is if you ask the speaker who's coming from California in a couple of weeks to talk about historic water on Mars, I'm sure they can give you a good answer. But it's an interesting question for historic actors. I don't remember anyone saying, well, could there be life on Mars but no water?
No one seems to come up with it.
Yeah.
Yes. You were saying that most of the things that the secretary has is anything within the features that the features that actually turn out to be particularly with the values Mariners or the
yeah, so the question is, did any of the features that Lowell drew as canals actually turn out to be not canals, but geological features? If I remember the Carl Sagan paper correctly, I don't think they were able to identify any coherent geological features that were definitively in the exact same location as Lowell had put them. Although, of course, there's a lot of error in play there. So as I say, Lowell's maps do have things like Syrtis Major on, but Syrtis Major is a much larger feature. Syrtis Major is hundreds of thousands of miles across, I think, or tens of thousands of miles across, certainly. It's a huge feature. So I'm not sure. I'd have to go and check the Carl Sagan paper again, but I don't think in the end they were able to definitively identify any, because I think, as I said, I mean, Lowell's argument was that he would be able to see a feature that was 2 miles across, but of course he was looking at telegraph wires against the sky to make an argument that he could see a dark line 2 miles across. So in actual fact, probably the features that you would need to be able to see in the telescopes of the time would need to be many, many, many miles across more than that. Do we know if any questions come through? Any more questions in the room? Yeah, no, they did. I mean, so the question is, did they look at Venus? Certainly, in the era of William Herschel certainly believed that Herschel believed that Mercury and Venus were inhabited. His argument was, as we saw, kind of broadly predicated on the concept that God would be able to create life that was adapted to any level of condition, no matter how inhospitable. After the development of the spectroscope and improved understandings of exactly how inhospitable Mercury and Venus would be, mainly in terms of their temperature, which was to say that they wouldn't be able to sustain liquid water. By the time you get to Proctor in the 1870s, he puts all his eggs in the Mars basket, and he explicitly says Mercury and Venus wouldn't be habitable. And in a certain sense, he leverages this as an argument for Mars, because he says, if you look at Mercury and Venus, they are just too hot. They can't sustain liquid water. Therefore, Mars, however, which while being colder than the Earth, isn't so cold that it can't sustain liquid water. That's what he thought. That's not actually true, but that's in part because, of course, bear in mind, any belief in life on Mars is predicated on the assumption that Mars has a functioning atmosphere. Of course, they assumed. And we know that for geomagnetic reasons, Mars lost its atmosphere a long time ago when it lost its geomagnetic poles. And if a planet like Mars had an atmosphere, it would have actually been able to sustain a viable water cycle. So their arguments went. But again, you'll hear, I think, potentially more about that in a couple of weeks' time.
Yes.
You touched on the idea of fictional representation, like the radio program in the late 30s, reflecting the social concerns of the time. I know that was in the run-up to the Second World War, where the industrialized nations were rearming. And I think there is a view that Wells was doing the same sort of thing at the end of the 19th century, when there was an arms race
Yes.
between the advanced nations.
Absolutely. So the question is about the influence on H.G. Wells and Orson Welles of concerns over military build-up and conflict at the time. And in both cases, yes, they're absolutely in play. I mean, as I said, typically H.G. Wells's novel, if you look at most literary assessments of it, the thing that they really focus on as the influence for the creation of that novel is British imperialism and the increased awareness at the end of the 19th century of the kind of atrocities that had been perpetrated by the British overseas as a colonial power, and that Wells was kind of reflecting and trying to make the British public sit up and think about what would happen if they were invaded. Because bear in mind, his novel is set in Surrey. The invasion happens just outside London and quickly spreads and takes over most of the south of England with mass fatalities. It's extremely bloody and grim opening to the novel. England gets laid to waste, basically. And yes, this is also not just a time of reflection upon British colonial power, but as you say, it's also a time that there's a growing genre of war novel and invasion novel, which reflects an increasing concern about the growing militarization of many of the major powers in Europe. So my argument for thinking also about concerns about ecological decay and Mars as a future Earth add into, rather than replace, any reading of the novel as a colonial or an imperial novel. And then with Orson Welles, obviously, the panic, the fear, is easier to understand also if you factor in that by 1938, there was already widespread concern about an impending global war. The Second World War was long foreshadowed for most people across the globe. There have been, by 38, a lot of people were really very worried that there was going to be another great war already. So that, I think, also, yes, should be factored in.
have a question on the chat. I have to read out to you.
Okay. Or if you can read it out into the microphone if you want.
So, is asking, is it possible that it is possible flashes of light or signals to developing large meteor impacts and unmeteorite by the model they have.
Yes, yeah, no, I'm sure that's right. I mean, like the canals, people are very interested to look back and think about, well, what did they see when they claimed to see flashes? And of course, there's multiple possible explanations. They could have been seeing impact on the surface of Mars, but of course, it could have been optical interference. It could have been something atmospheric. I think there are multiple explanations, but certainly that's quite plausible that these flashes that were seen. Because again, the important thing to report about these flashes is that these were reported by very senior and widely respected astronomers. These were not reports from people, unknown amateurs. The Modon Observatory in France was reported, one of the most widely reported light flashes in 1894, and that's the National Observatory, one of the national observatories in France. So it's quite possible that what they saw was something really happening, just not Martians sending light signals. And I think, did we have a question?
More recently, fighting probes were sent to look for the possibility of life on Mars. And some of the images that were sent back, they actually saw what they thought was a face.
Mm-hmm.
I think it was something like they saw a face on Mars. And there were other structures as well that appeared to be pyramids and things. It sent quite a few scientists thinking, oh, this must be artificial.
Yeah. So the question is about the next great Martian life sensation, which was the Viking image of the face on Mars, which I'm sure many people will remember and have seen, which is this quite striking image of what looks like an edifice that's built that looks like a face. But of course, one of the things that's different about that account is, and I've not studied that episode in comparison, but from what I can remember about it and looking into it, is that episode very rapidly became much more associated with kind of paranormal and fringe belief in life on Mars. And mainstream astronomy was much quicker to kind of shut it down and say, no, this is just, it happens to be the angle of the sun on this object, just happens to have fallen in just the right way to make this shape. And if the sun was anywhere else, it wouldn't look like that at all. And so I think there's a difference there in that I think that pretty soon after the Mariner images in the 1960s, mainstream belief that there would be life on Mars kind of really evaporated. And quite quickly, astronomers themselves and planetary scientists turned their attention to looking for geological rather than biological evidence. Question? Thanks.
What I'd like to know is, if we found life on Mars right now, would they tell us? I mean, like, things are coming in, having locked up. The whole fight, we can't even handle that. And that's what I'd like to know, actually. How much of what they find would they actually tell us?
Okay, so this is more of a philosophical or an ethical question. So this is a question about if life was detected now, let's say either extraterrestrial life generally or life on Mars, would they tell us? Well, I think they definitely would, because I think the scientists would not necessarily be particularly concerned about the broader issues and ethical implications. not that I'm aware of, not at that scale, because I don't think necessarily, but I don't think at the moment there is necessarily a government body, say, that is so preemptively concerned about the implications that they would try and keep it under wraps. That could change if they got close to a discovery and found out about it, and then they might say. But I mean, the other thing you've got to remember about modern science is it's such a large-scale endeavor. It's thousands of people. Even the search for extraterrestrial life as it's currently constituted, it employs thousands of people. So I don't think it would really be, my guess is it wouldn't be possible to cover it up and to not, someone would say something. Whether it came out in a neat and coherent package, or whether it came out and caused I mean, really, I think the implications for discovering extraterrestrial life, I don't think they would necessarily cause a great deal of consternation or panic, because I don't think it's likely that what we would discover would be an immediate threat. I think it's more, the implications are interesting philosophically and ethically, because if you think about the effect of the Copernican revolution had on decentering humans' understanding of their own self-importance. And actually, Copernicus says, no, actually, the Earth is just orbiting one of many stars. We're not special. I think we would have something like a second Copernican revolution if we found extraterrestrial life, because it would be further substantiation of a point that humans aren't necessarily as special and important as we might think we are. I mean, as far as I'm aware, no, because all of the planets out to Saturn are visible to the naked eye. You don't need a telescope to see them. So Uranus was the first planet discovered in the quote-unquote modern era, William Herschel, using a telescope. So Uranus, Neptune, and Pluto, you need a telescope to see. But everything out to Saturn was known, and we have records of the motions of all the planets out to Saturn going back to the Babylonians, which is the oldest astronomical records we have, I believe, which are about 4000 BC. Yeah, potentially. But I don't think that they had anything, I'm not aware of them having anything beyond Saturn. How are we doing?
I think we'll bring it to an end. No more questions. Okay, well, many of us may have known about the Herschel Batman and Lowell's canals and, of course, the War of the Worlds, but we probably didn't know very much of the background and what there was in between. And we've had a lecture which has really enriched us with all that background knowledge, and for that I'm very thankful. So it would be great if we could all thank Joshua in the usual way.